Now we're going to look at a proof that involves using the right angle congruence theorem. We start off, of course, with what's given, which is AB is perpendicular to BC and DC is perpendicular to BC. And if you notice, we've shown that on the figure by marking the right angle at angle C and angle B. So we start there, and marking the figure is very important. We write down what's given, and our reason is it's given. By marking the figure, we're able to write our next statement. Our next statement is angle B and angle C are right angles. And we know we had a theorem that stated that, actually we had a definition that stated that if we have perpendicular lines, then they form right angles. So the reason for this would be definition of perpendicular lines, or you can simply state perpendicular lines form right angles. Finally, we can state that these two angles are congruent, and the reason for it is the right angles congruence theorem, which states that all right angles are congruent. So that saves us a couple of steps there. Otherwise, what we'd have to do is we'd have to state that they're both equal to 90 and then set them equal to each other and then finally change them to congruence. So it does save us a couple steps. This next proof, what we're going to do is prove a case of the congruent supplements theorem. So if we look, we've got angle 1 and 2 are supplements and 2 and 3 are supplements, and we want to prove that these are congruent. We're going to do it on a separate page, but we've talked about this before. Basically, we want to show that those are congruent. For example, if this was 50 degrees, this would be 130. If this is 130, then this would have to be 50 as well, making those equal. So that's more of an inductive proof. We're going to do it using deductive reasoning with a formal proof. We start with what's given to us, and the reason is it's given. Then what we do is we write out what the definition of each of these is. If they're supplements, then they equal 180. So we can say 1 and 2 are equal to 180, and 3 and 2 are equal to 180. And the reason for that, again, we went from the name of something to what it means, so that is a definition. In this case, definition of supplementary angles. Now, since they're both equal to 180, then we can also state that they're equal to each other. If we do this, this is not transitive. In this case, this would be even though it says transitive. This would not be considered to be transitive in my book because it's not first equals second, second equals third. So ignore where it says transitive. This would actually be substitution property. Then, remember, we want to state that 1 and 3 are congruent. If you notice, there's a measure of angle 2 here and a measure of angle 2 here. We can subtract that out, and that gives us the measure of angle 1 is equal to the measure of angle 3. Again, the reason there is subtraction property of equality. Finally, and I think I've talked about this before, whenever we go from equality to congruence or congruence to equality, we would state that the reason for that in this case is the definition of congruent angles. So if those were segments and we did the same thing, it would be definition of congruent segments. In this case, it would be definition of congruent angles. And we've gotten where we need to go. Alright, it says how many steps did you save in the proof? In example 1, by using the right angles congruence theorem. I already talked about that. If we go back to it real quick, let me just get to it. If we had not had the right angles congruence theorem, we would have had to state that they're both equal to 90 because the definition of right angles, and then we'd have to set them equal to each other by substitution, and then finally we would get to this step. So we're actually skipping 2 steps because we have that right angles congruence theorem. And so 2 steps. Then for this last one, we want to actually write out a whole proof for congruent complements. So everybody's would be a little bit different, but here's an example of what it would look like, and it would be a very short proof. This is what the given and the proof would look like. Very similar to the congruent supplements theorem. So we would have 1 and 3 are complements, 3 and 5 are complements, and we would want to prove that 1 and 5 are complements. So we would simply state that they're given, And therefore, by the congruent complements theorem, we know 1 and 5 are going to be congruent as well. If we didn't have the congruent complements theorem, we would have to write it out similarly to the way this one is, and it would take us 5 steps. Okay? And I believe that's it. Thanks.